The first 20 or 30 pages of the text are providing tools, basically math techniques, math concepts, notations, definitions, stuff like that. All prerequisite stuff for later chapters. And this chapter is labelled Chapter 0, so like a preliminary chapter. It's fairly short, only about 20-30 pages. And by the end of this board, 4 sessions, we will have done nearly a half of it. So, getting through at a fair clip, fair speed. Right, so just lots more definitions and concepts, mathematical concepts and tools just thrown at you. For a lot of you, this is old stuff, just be revision. For those of you for whom it's new, there's a lot of memory work you'll need. So get to it. All right. So just a whole list of new concepts and terms and so forth. So here's just continue on from the previous session. The notion of a Cartesian product, labelled in 2 ways. An alternative to the Cartesian product is a cross product in the context of sets, not vector calculus. The cross product has the same term, has a very different meaning. But in the context of sets, usually just talk about the Cartesian product. And it's a product usually of 2 sets, so just say A and B. And you write it this way, so A cross B, that's where this cross product term came from. There's an alternative label to the usual Cartesian product, so A cross B, right? And what is it, by definition? Well, it's the set of all possible ordered pairs, x comma y, where x is taken from set A and y is taken from set B. Okay? So where x belongs to A, set A, and y belongs to set B. So it's all possible pairs you could have. So for example, if set A had m elements and set B had n elements, then the number of possible pairs, ordered pairs like this, would be m times n, so mn possible pairs. So the size of your set, your Cartesian product, would be mn. Right? So here's an example. When I say ex dot, so it just stands for example, and this number here corresponds to the example number in the textbook, so you can follow it fairly closely. Right? So if you get the text. Oh, by the way, about the text itself, getting it. You have 2 choices. If you prefer electronic form, you can get it for free on emule.com. So emule, emule.com. So just download the software to set up Emule on your computer, and then you just type in the books that you want, title, author, whatever search technique you use, and then you can just download the textbook for free from Emule. Now, if you prefer hard copy, you'll have to pay for it. You can probably get it fairly cheaply second-hand on Amazon.com. So just go to Amazon and type in the title when you're searching for the book, the author, the title, and you can probably get it fairly cheaply second-hand. So you have a choice. So if you live in a poor third world country and you can't afford even a second-hand book from Amazon because Western prices too expensive, then you can get it for free. But you can't. To be able to look at this, you have to have a computer, so you would have to then download it from Emule for free onto your computer, your laptop or desktop. Okay, so this corresponds to the example number in the textbook, so it makes it easy to follow where I am in the lectures, in these YouTube videos, and where I am in the textbook. And I follow the textbook pretty closely, deliberately, so it makes it easier for you. Okay, so here's an example of a Cartesian product. I take two sets, pretty simple sets, because I don't want to have to write out too much. Same in the book. So if set A is just consists of two elements, 1 and 2, and set B consists of three elements, x, y, and z. Therefore, A cross B, the Cartesian product, is all possible ordered pairs of these two sets, the numbers. So you'll do it systematically. So you'll have 1x, 1y, 1z, right? 1x, 1y, 1z, and then 2x, 2y, 2z. Okay? Now, you can generalize this idea. You can take the Cartesian product of several sets, let's say k sets, and the first set, say A1, and then A2, dot, 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 AK, and you write it out this way. This is how it's written. So we're talking now the Cartesian product of k sets, right? Usually different sets. So A1 time cross A2 cross dot 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 cross AK. And what is this Cartesian product? Its elements will be k tuples. Remember what a k tuple was? We did that 2 sessions ago on the previous board. A k tuple is just a list of elements, and there'll be k of them because it's a k tuple, right? So separated by commas. And the ith one, see in the middle here somewhere. So the AI would be a member of the big AI set, and all possible k tuples like this you have, they are the elements of the set, which is this Cartesian product of k sets. Okay, so it's a fairly straightforward generalization of this. So this is a pair. It's a two tuple, if you like, a pair. And this is a k tuple because you have k elements here, and here you only have two. Right? So here's another example. So here's example 0.6. So A and B as are above, so just like this. But now you're taking a Cartesian product of three sets, in a manner of speaking. Strictly speaking, two, but three in this sense. A cross B cross A. Again, do it systematically. So let's change the right-hand one fastest, and then we'll modify the middle one next, and then the slowest change speed, the first one. So what I mean by that is so it'll be 1x1, and then change this one next. Okay, so 1x2. So you've exhausted the A's. So next you'll change the